Okay, so we have angle ABC of triangle ABC is a right angle. The sides of triangle ABC are the diameters of the semicircles as shown. The area of the semicircle AB equals 8 pi, so A to B right here, that semicircle has an area of 8 pi. And the arc of the semicircle on A to C, so this arc right here, has a length of 8.5 pi. What is the radius of semicircle B to C? So the radius of this semicircle B to C. So the first thing we want to notice is that we're looking at a right triangle, right, where ABC right over here is our right angle. And from that, we know we can use the Pythagorean theorem. We know that we have information about the area of AB, and we know we have information about the arc of A to C, which means that we can most likely find the length of this hypotenuse and one of the legs of the triangle, and use that to find the length of B to C, and then find the radius. So I've labeled them with different colors so we can make sure to stay organized. And let's start with A to B. So what we have is an area of a semicircle that equals 8 pi. And we know that the formula for the area of a circle is going to be pi r squared. So let's start by inserting that equation. So we have pi r squared, and then we're going to have that equal to the area of the semicircle. Now the area of the semicircle is 8 pi, but the area of the full circle has to be 16 pi then. So we're going to have an equation that looks kind of like this, where the area of the circle, pi r squared, is going to equal the area of the semicircle times 2, which would be 16 pi. And if we solve that, what we're going to get is, we're going to get that that r squared is going to be equal to 16, which means that r is going to be equal to 4. And since this length from A to B is a diameter, we're going to have a diameter equal to 8. So that's our first metric that we've solved for, and I'm going to label that right over here. So that's going to be equal to 8. Now, for A to C, we have to use a different formula. Since we're told that the semicircle of A to C has a length of 8.5 pi, we can infer that that would be half of our circumference. And we know that the formula for the circumference is going to be pi times diameter, and that's going to equal the length of A to C times 2, because A to C is only half of our circumference. So we're going to do 8.5 pi times 2. So our equation should look like this. Pi times the diameter equals 8.5 pi multiplied by 2. Now if we continue to solve that, right over here, let's do that in red. We're going to have pi times diameter equals 17 pi. Okay, so that's going to be our formula for this. And if we keep solving that, we're going to divide both sides by pi and have a diameter of 17. So this length right from here to here is going to be 17, which we're going to draw right over here. 17. From here, we can use the Pythagorean theorem to find our last number right over here. So we know that our Pythagorean theorem is going to be a squared plus b squared equals c squared. Just like this, right? And we know one of the legs, so it's going to be a squared plus b squared, which we're trying to find, equals c squared, which is going to be 17 squared. Now if we do that, we're going to have 8 squared, which is 64, plus our b squared, which we don't know. That's going to be equal to 17 squared, which is going to be 289. Right, so that should simplify to this. And if we continue doing the math, we're going to get that b squared is going to be equal to 225, which means that our b value, b squared is going to be 225, which means that our b value is going to be 15, right? So that means that this length, let's do that in blue, is going to be 15. Now our question asks us, what is the radius of the semicircle in BC? Now B to C, this is going to be the diameter, which means that the radius is actually going to be 7.5. So we should have our answer should be B.